My dear friends, students, and viewers, this is Sir Palmat and welcome to my video channel. So today, we are talking about the solving radical expressions, which are part of grade 9 mathematics lesson. So today, here is our learning objectives for today's lesson. So first, you'll be able to apply the properties of equality in order to solve radical equations. And second, you'll be able to solve and check radical equations. So these are only two objectives you need to study and learn, which are part of their lesson for grade 9, which we are talking about solving radical expressions or equations. So my dear learners, students, and viewers, so are you ready to study and learn more about radical equations? So let's start. So today, we are talking about radical equations. So what is a radical equation? A radical equation is a type of equation in which one or more radicands contains variables. So here are some of the examples of radical equation looks like. So we have the square root of a plus 2, which is equal to 4. So another radical, so the square root of 2m minus 8 minus 4 is equal to 2. And then we get the fifth root of the 2x minus 3 is equal to 2. And another, the square root of k minus 1 is equal to the square root of k minus 5. So these are some of their examples. Looks like a radical equation. So such equations can be solved by isolating the radical of one side of the equation, then raise both sides of the equation to an appropriate power in order to eliminate the radicals. After each side of an equation has been raised to a power, a new equation will be formed. So this is the same manner in solving linear or quadratic equations in order to solve for a one variable. Okay? So it is possible to obtain a solution to this new equation that are not solution to the original equation. Such solution is what we call the extraneous solution. When we say extraneous solution, it is the only root or a solution that cannot be a part of their kind of equation, which makes both of the equations are false. So meaning to say that when you substitute the given one value of a variable, that makes both the equations or sides of the equation are not equal. So that is extraneous solution. So that is why, my dear learners, it is essential to check all the results in order to verify the correct solution. So always remember, you always going to check by substitution and check both sides of the equation, but both numbers are equal. Okay? My dear viewers, so now to come up with a lesson which we are talking about radical equations. So to study some of their illustrative examples which involves radical equations on how will you solve for an indicated variable. So let us begin with our first illustrative example. So solve for the value of a in the given variable or the given equation, so which is the square root of a plus 2 is equal to 4. So to solve this kind of radical equation, here is the solution. So first, we let that given radical equation a plus the square root of a plus 2 is equal to 4. So since the radical expression is already isolated on one side, you just need to raise both sides of the equation to the second power, or known as squaring both sides. So in this process, enable to eliminate that kind of radical sign, so you have to square it both sides. So the first step, we have the given, and follow up, we have to squaring both sides of an equation in order to eliminate the radical sign of the left side. Okay, next is after you get the squaring both sides, so now you have already eliminated the side, so it remains a plus 2 on the left side, and we get the perfect square of 4, which is 16. And then you'll be going to isolate by subtracting both sides by 2. So a plus 2, it becomes a minus 2. So positive 2, it becomes negative, and copy 16 on the right side. So subtract both sides of the equation by 2. Okay, and after that, you will be going to simplify. So 16 minus 2, which is 14. So that the value of a is equal to 14. So let's find out if the solution is correct. So by checking, we need to substitute when the value of a is equal to 14. So you are going to substitute into given equation. So the value of a is 14, so it becomes square root of 14 plus 2 is equal to 4. And then we get the sum of these two numbers. So it becomes square root of 16 equals 4. And then after that, so the value of square root of 16, which is 4. So now 4 is equal to 4. So both sides of the equation are the same. And it is true for all values of a. And that is the one only solution, which is a is equal to 14. And that is the final answer to the given equation or the solution. So let's move on to our next illustrative example. So for number 2, how will be able to solve for the value of m in the given equation? So the square root of 2m minus 8 minus 4 is equal to 2. So to solve this kind of radical equation, the one of the variable m, here is the solution to the given radical equation. So to solve this for the value of m, so we have to copy the given equation, but we mark as color violet. So the marked violet, in order to us to isolate from constants into variables. So we have to add both sides of the equation by 4. So from negative 4 transfer to the other side of the equation, so it becomes positive 4. And then you'll be able to simplify the right side of the equation. So 2 plus 4, which is equal to 6. After that, you will be going to squaring both sides of an equation since on the left side has a radical sign. So in order to us to eliminate the radical side, so that is squaring both sides. So the quantity of square root of 2m minus 8 squared plus 6 squared. And then you are going to simplify. So squaring, so eliminate the radical sign, so it becomes 2m is equal minus 8, and 6 times 6, it becomes 36. And then you'll be going to add by 8 both sides. So since negative 8, transfer to the other side of the equation, and it becomes positive 8. So 2m is equal to 36 plus 8. And then you'll be able to combine 36 plus 8. So to simplify the right side, so 2m is equal to 44. And to solve for the value of m, so since 2 is one of the numerical coefficient of m, so we have to divide the given numerical coefficient of m both sides of the equation, so which is 2. So to divide 2, so cancel out the 2, it remains m. 44 divided by 2 is equal to 22. So that is the value of m, which is equal to 22. So let's find out if the given solution, the value of m, when you substitute, it satisfies the statement is correct. So to check that, we need to substitute when the value of m is equal to 22. So here is the given equation, and then you will be going to substitute when value of m equals to 22. So 2 times 22 minus 8 minus 4 is equal to 2. So then simplify inside the radical. So 2 times 22, it becomes 44 minus 8. So that is square root of 36. Minus 4 is equal to 2. And then simplify the square root of 36, it becomes 6. Minus 4 is equal to 2. And then 6 minus 4, so we get the difference, which is 2 equal to 2. Okay? So 2 is equal to 2. So the statement is true. Thus, the solution is m is equal to 22. And that is the final answer. So now you know, my dear friends, students, and viewers, on how we're able to solve for the value given the radical expression. So to learn more, some of the illustrative examples. So start with illustrative example number 3. Solve for the indicated variable. The square root of 4f plus 12 plus 7 is equal to 1. So to solve this kind of radical expression, here is the solution to the given expression. Okay, so given that, the given radical expression or equation, so that you mark color red means that you have to able to transfer this constant term to the other side of the equation. So positive 7, it becomes negative 7. And then 1 minus 7, so it becomes negative 6. So the larger is the negative value than the positive. So it becomes negative 6. Simplify the right side. And then you'll be able to squaring both sides of an equation. So that is the quantity of the square root of 4f plus 12 squared is equal to negative 6 squared. Okay, next is do the squaring both sides of the equation. So we can eliminate the radical sign. So it becomes 4f plus 12 and equal to negative 6 squared. So that is negative 6 times negative 6. That is 36. And then you have to transfer positive 12 to the another side of the equation. So positive 12, it becomes negative 12. So the remaining here is 4f. So it's equal to 36 minus 12. So subtract both sides of the equation by 12. And after that, you'll be able to simplify the right side. So 36 minus 12, so it becomes 24. And then, since the given numerical coefficient of f is 4, so to solve for the value of f, so divide by the numerical coefficient of f. So divide by 4, so 4 divided by 4, it's 1 or f na lang. And 24 divided by 4, it becomes 6. So that is f is equal to 6. And that is our solution to the given equation. But to check that if the statement of the equation is correct, so let's substitute for the value of f equals to 6. So we let f equal to 6, so substitute. So for f, it becomes 4 times 6 plus 12 plus 7 equals to 1. And then you'll be able to simplify 4 times 6, so it becomes 24 plus 12 plus 7 plus 1. And then simplify the inside radicand, so 24 plus 12, it becomes square root of 36 plus 7 equals to 1. And then simplify square root of 6, that is 6 plus 7 equals 1. So 6 plus 7 is equal to 13. And 13 is equal to 1, so no, it is false. That is 13 is not equal to 1. And it is considered as extraneous solution. So my dear students, why is it is extraneous? Because this solution is not part of the given equation. If when you substitute the given values of f, if the statement, both sides of the equation are not equal, so that is false. So f is equal to 6 is not part of the solution and it is considered as extraneous. So therefore, the given equation has no real solution. Okay? So now you know, my dear learners. So you know that there is no real solution in the given equation. So let's move on to our next illustrative example. So how will we be able to solve the square root of 17 minus 4g is equal to g plus 1? Okay? To solve this kind of equation, so what we'll be able to do is to copy first the given, and then you'll be able to squaring both sides of the equation. So it becomes the quantity of 17 minus 4g squared is equal to g plus 1 squared. And then simplify both sides of the equation simultaneously. So on the left side, we eliminated the radical sign. So since we get the perfect square, so it becomes 17 minus 4g. And we get this on the right side by the use of special products using the the squaring of the binomial. So that is g, the perfect square of the first term g is g squared. Next, the perfect square of the last term 1, which is 1. And for the middle term, so we get the product of the first and last term. So 1 times g is equal to g times 2. So that is 2g. Okay, for the middle term, so don't forget to get the product of the first and last term and get the twice of it. So g squared plus 2g plus 1. And then you'll be able to equate all of this by 0 in order to ask, since it is quadratic. So 17 transfer to the other side, so it becomes negative 17. Same with negative 4g. So negative 4g transfer to the other side, it becomes positive 4g. And then simplify or combine like terms. So g squared, so copy. 2g plus 4g, it becomes 6g. And 1 minus 70, so the larger is the negative value, so it becomes negative 16. Okay? So we use the symmetric property of equality. So the 0 must be on the right side of the equation. And then we'll be able to factor out this kind of quadratic trinomial. So we have g squared, so g times g. And of course, the sum is the sum is positive 6 and whose product is negative 16. So we find two numbers. So we all know that the sum of 6, which is 8 and negative 2. So that is 8 minus 2, so which is 6. And the product is negative 16. So we find one positive and one negative. And that is 6 and we have 8 and 2. So 8 times 2 becomes 16. So positive times negative, so that is negative. Okay, so that is the factor form of this quadratic trinomial g squared plus 6g minus 16. The next step to do is to equate each of these factors by 0. So that we are using the multiplication property 0. So g plus 8 is equal to 0 and g minus 2 is equal to 0. So again, we will use the multiplicative property of equalities by use 0. And then, so solve for the values of g. So we transfer to the other side. Positive 8 becomes negative 8. Same with negative 2, it becomes positive 2. So these are only two solutions. G is equal to negative 8 and g is equal to positive 2. So let's find out if one among of these two solutions are correct. So here is our checking right now. So we need to substitute when g is equal to negative 8 and 2. So let's start with substituting the value of g is negative 8. So when you substitute the value of g, so it becomes 17 minus 4 times negative 8, so that is equal to negative 8 plus 1. So refer to the original equation. And then you will be able to simplify negative 4 and negative 8. So it becomes positive 32. So negative and negative, it becomes positive. So copy 17, so get the square root 8 minus negative 8 plus 1. So that is negative 7. And after that, you'll be able to simplify square root of 49, which is equal to negative 7. So, negative 49, which is equal to 7. 7 is equal to negative 7? It's not. So, 7 is not equal to negative 7. And it is considered as extraneous solution. Therefore, g is equal to negative 8 is not part of the solution to the given equation. So, how about when g is equal to 2? So, in the same manner, we'll be able to substitute the value of g to the original equation. So, it is the same manner. So, 4 times 2, it becomes 8. So, 17 minus 8, it becomes 9. So, square root of 9 is equal to 3. Therefore, 3 is equal to 3. And one of the solution is true. So, true solution. Therefore, g is equal to 2 is the only solution to the given equation. And that is the final answer. So, let's move on to our next illustrative example. So, how will you solve the square root of k minus 1 is equal to the square root of k minus 5? So, to solve this kind of complicated radical equation, so here is the solution to the given problem. So, given the equation, so the first step to do is to equate both sides of the equation by squaring. Okay? So, squaring both sides of the equation, and then you'll be able to eliminate the right side of the equation, which is the radical sign. So that is k minus 5. And then square root of k minus 1 quantity squared. So we are applying the special product using a square of the binomial. So the square root of k, so we get the perfect square of square root of k, which is k. And then the perfect square of negative 1 is positive 1. And then we get the middle term. So the square root of k times negative 1, that is negative 1 times 2, so we get the twice of that, that is negative 2 square root of k. So k minus 2 square root of k plus 1 is equal to k minus 5. Okay, the next step to do is to isolate, and then you have to transfer the value of k, so k minus k. And then, of course, say with positive 1. So transfer to the other side, so it becomes positive, positive becomes negative 1. So, negative 2 square root of k is equal to negative 6. So, we eliminate the value of k since the value is 0. Then, negative 2 square root of k is equal to negative 6. So, square root of k is equal to 3. So, both negative, both sides of the equation. So, we eliminate negative side. So, 6 divided by 2, so we get 2. And then, we get the square both sides. So, in order to us to eliminate the square root. So, the square root of k squared is equal to 3 squared. So, the value of k, which is equal to 9. And that is one of the solution to the given equation. So let's find out if the equation is true. So to check, we need to substitute when k is equal to 9. To substitute simultaneously the value of k, so that is square root of 9 minus 1 times the square root of 9 minus 5. So it becomes square root of 9, it becomes 3 minus 1, which is equal to 9 minus 5, that is square root of 4. And then, so simplify 3 minus 1, it becomes 2. Square root of 4 is also 2. So 2 is equal to 2 and the solution is true. So one of the solution, k is equal to 9, is true to the given equation. Therefore, k is equal to 9 is the only solution to the given equation. Okay? So let's move on to our last illustrative example, the set of problems. So solve each of the following radical equations. For letter A, the cube root of x is equal to 5. Letter B, the fifth root of 2x minus 3 is equal to 2. And for letter C, the fourth root of x minus 35 is equal to 10. So to solve this set of radical equations, indicated the variable, here is the solution to the given set of problem. For letter A, we have cube root of x is equal to 5. So copy the given equation and of course, to extract cube roots both sides. So in order to us to eliminate the cube root symbol, so we have to get the perfect cube both sides. So eliminate the cube root and it's the exponent, so remain as x. So we get the value of 5 cubed, that is 5 times 5 times 5, so we get 125. So the value of x is equal to 125 and that is the final answer to the given equation. So one solution, x equals to 125. Okay, let's move on to letter B. So the fifth root of 2x minus 3 is equal to 2. So this is the same manner to do. So we'll be able to get the fifth root or the perfect fifth power both sides of the equation. So the fifth root of 2x minus 3 raised to the power of 5 is equal to 2 to the fifth power. Okay? And then we eliminate the exponents. So 5, of course, the remaining is 2x minus 3 is equal to 32. So 2 to the fifth power is 32. So 2 times 2 times 2 times 2 times 2. So there are only 5 2's. We get the product, which is 32. And then we'll be able to isolate. So transfer negative 3 to the other side of the equation. So negative 3, it becomes positive 3. So that is 2x is equal to 2x plus 3. And we get the sum, which is 35. So we get 2x. So 2x equals to 35. Therefore, x is equal to 35 over 2. So always remember when you express the answers into common fraction. So that is the final answer. Okay? And for letter C, how about the fourth root of x minus 35 is equal to 10? So again, we'll be able to extract or we get the perfect fourth power both sides of the equation. So the fourth root of x minus 35 is equal to 10. So we get the perfect fourth power. So the fourth root of x minus 35 raised to the power of 4 is equal to 10 to the fourth power. And then we expand this. So we eliminate the exponent, so 4, as well as with the radical sign. So x minus 35 is equal to, so 10,000. So because 10 to the fourth power is 10 times 10 times 10 times 10. So that is 10,000. And we transfer to the other side of the equation. The negative 35, it becomes positive 35. And then we have to copy this. So x is equal to 10,035. And that is the final answer to the given solution or equation. So that's the end of our video. So my dear learners, so now you know how to solve radical equations in finding the given, the indicated variable. So thank you very much for watching. So please like, share, subscribe, and hit the notification bell here at Sir Palma TV on YouTube channel. So see you on next video. So thank you very much for watching and God bless us all.